All right, Unit 5 focuses on the properties of a triangle. Before we talk about specific properties of triangles, we're going to focus on perpendicular and angle bisectors. And if you remember, a point, it's the same distance from two or more objects. The point is said to be equidistant. I think we've used this word before when we were talking about a midpoint. So a point that's the same distance from two or more objects, that point is said to be equidistant. We're going to use that word in our definition for the theorems of a perpendicular bisector and angle bisector. So first, for perpendicular bisector, you can see right here, this line, CD. CD is a perpendicular bisector because this right angle means it's perpendicular, and then these two congruent markings means it's bisecting. It's splitting this segment AB in half. So we're going to state that if a point is on the perpendicular, that's our sign for perpendicular bisector, of a segment, then it is equidistant from the endpoints of the segment. All right, and you can see that in this diagram here. C is a point on this perpendicular bisector, and these two congruent markings mean it's equidistant from the two endpoints of the segment. All right. The converse is also true. So the converse then would state that if a point like C is equidistant from the endpoints of a segment, then it's on the perpendicular bisector. So if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. And that's what we have right here. We have C and D. Oh, we don't know if D is equidistant yet, but we know that C is because it has these congruent markings here. So then we could state that CD is a perpendicular bisector, and it's perpendicularly bisecting AB. So this would be a 90-degree angle, and these two halves would be congruent. Okay, let's use that theorem to find some missing measures in the following figures. Let's go ahead and do A and D together, and then you can finish these next three. We're trying to find the length of MN right here. Okay, and if we know that line NP is a perpendicular bisector, 90-degree angle, splitting that segment in half, then N has to be the same distance from the two endpoints. So 2.6 to L and 2.6 to M. The length of NM would be 2.6 as well. All right, let's try D. DE is 20, DG is 35, and EG is 35. So this would be using the converse here. We want to find EF, this length right here. And hopefully you're able to notice that G, it's the same length to D as it is to E. They both have a length of 35, so they're both congruent. And we stated up here in the converse, if a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector. So that means this line right here, line L, is a perpendicular bisector, 90-degree angle. These two parts are congruent. If this whole length is 20, then each of them would have to be 10. 10 and 10. All right, go ahead and try B, C, and E on your own, one at a time here. For B, we're trying to find the length of BC. Again, A is the same distance to the two endpoints on that segment, so that means AD is a perpendicular bisector. So these two segments would be 12 and 12, which gets you a length of 24 for BC. For TU, we need to use a little bit of algebra here. U is on the perpendicular bisector, right? UW, it's a perpendicular bisector shown by these markings. So that means these two lengths would be congruent, the lengths to the two endpoints. So if they are congruent, we can set the expressions equal to each other and solve. Move the 3x over, add your 3 over. We get 12 equals 4x. And we get x equals 3. So then the length of TU, we're going to plug our 3 in. We get 3 times 3 plus 9, which is 18. And then finally for E, if EG is 14.6 and you're told that L is a perpendicular bisector, half cut in half, then both the lengths need to be the same on both sides. The length from G to the two endpoints would need to be the same because L is the perpendicular bisector. Okay, you're going to see a similar property for an angle bisector. Let's go ahead and list that definition out. So our angle bisector theorem states that if a point is on the angle bisector, so now we're referring to point D, if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. Okay. So you can see that this is an angle bisector because of these congruent markings. This ray right here is splitting the angle in half. So D's on the angle bisector, which means it's going to be the same distance from the two sides. These two lengths are going to be the same. And the reason you need these 90-degree angle markings here is because the shortest distance between 2 points is a straight line. So a straight line to each side would be forming a 90-degree angle. That's why we need to have those two markings there. DB is equal to DC. Okay, let's do the converse. The converse would state that if a point in the interior, point P, is the same distance to the two sides of an angle, then it's on the angle bisector. If a point in the interior of an angle is equidistant from the two sides of an angle, then it is on the angle bisector. Then it is on the angle bisector. And that's what you have here. You have P being the same distance to side AC as it is to BC. That's what these congruent markings mean. 90-degree angle mean it's the shortest distance between 2 points, a straight line. Therefore, we can state that CP bisects angle ACB. It's an angle bisector. All right, let's use those two theorems to find some missing measures here. Let's do the same thing. We'll do A and B together, or A and D together, and let you solve B, C, and E on your own. Hopefully you can see here, AC, this is an angle bisector. You have your two congruent markings. So that means C, the point on the angle bisector, is going to be the same distance to both sides of the angle. So 7.2 and 7.2. BC would have a length of 7.2. Let's try D. We got to fill some information in here. Angle WYZ is 63 degrees. And then we're told XW is 5.7 and ZW is 5.7. So these two lengths are congruent. That means that W, this point in the interior, it's the same distance to the two sides. It's the same distance to side YX as it is to YZ. So then that would mean that this ray right here is an angle bisector. So angle XYZ, the whole thing would be 63 and 63, getting us 126. Okay, try B, C, and E on your own, using the angle bisector theorem and the converse. For B, EFG is 50 degrees. EFG is 50 degrees, which is the whole thing. If we want to know what EFH would be, EFH, that's going to be half of this angle because FH is an angle bisector because H is the same distance to the two sides. So this would be 25 degrees. All right. For C, M is the same distance to the two sides again. That's what these congruent markings mean. 90-degree angle means it's the same direct route to each side. So then this angle, these two angles will be congruent because KM is bisecting angle JKL. So 3A plus 20 equals 2A plus 26. Congruent angles means their measures are equal. When we solve here, we get subtractor 20, A equals 6. Don't forget to plug that back in for angle MKL. 12 plus 26 gets us our 38 degrees. And then finally for E, you're told that YW is bisecting angle XYZ. So that would mean these two lengths are the same, the length from W to both sides of the angle. And if WZ is 3.05, then WX would also be 3.05. Right. Okay, the last two things I want to finish up with, we have one more theorem, but before we do that, I want to talk about writing the equation of a perpendicular bisector. So if I were to give you 2 points, and we would graph this segment, 6, -5, and 10, 1, CD, and we wanted to write the equation in point slope form, which if you remember is y minus y1 equals m times x minus x1, where we need to plug in our point and our slope for point slope form. Well, we want the equation of the perpendicular bisector. So we don't want the equation of this segment. We want the equation of the line that is perpendicularly bisecting this segment. So we need to find two things. We need to find the slope of this segment, because then we can find the perpendicular line. And then we need to find the midpoint. So let's first find slope. That would be up 1, 2, 3, 4, 5, 6. To the right, 1, 2, 3, 4. So this is a slope of 6/4 or 3/2, which means the slope of the perpendicular bisector is going to be the opposite reciprocal. Perpendicular lines, slopes are opposite reciprocals. So our new slope would be -2/3 for the perpendicular bisector. We need to find the midpoint. Remember, midpoint is like finding the average. So 6 and 10, the number right in the middle would be 8. -5 and +1. The point right in the middle, if it's harder for you to see because you have a negative and a positive, you could just add those two and cut it in half. Hopefully you remember seeing that formula. -4/2 gets us -2. So 8, -2, yep, that looks like it's right in the middle. And if we use the slope of down 2 to the right 3, we're going to be a little off, so let's go up 2 to the left 3. You can see that this line right here is definitely splitting it in half, and it's forming a 90-degree angle. That's your perpendicular bisector. The equation of that line, you just need a point and a slope, and you have both right here. Slope, point. Let's write the equation. Y minus -2, so +2, equals -2/3 times x minus 8. Okay. Why don't you try the same thing here for points P, Q. P is at -5, +4. And Q is at 1, -2. Remember your steps. You need to find the slope, find the slope of this segment, the slope of the perpendicular bisector, and the midpoint, and then you can write your equation. All right, give this a shot. Hopefully you could have seen that the slope is -1 of this segment. So then for the perpendicular bisector, the slope would be the reciprocal of 1 is just 1, and then the opposite of -1 is +1. And then the midpoint should have been -2, +1. If you want to double check, plot that point. You can see it's right in the middle of the segment. So then the equation of our line would be y minus 1 equals, you can put 1 if you want, or you don't have to put anything there, 1 times x minus -2, or x plus 2. Okay. All right, our one last theorem we need to finish up with is from 5.4, but we're just going to move it to this section. The midsegment of a triangle is a segment that joins the midpoints of two sides of a triangle. Every triangle is going to have 3 midsegments because we have 3 midpoints all connecting. So there's your 3 midsegments. You know these are midpoints because of these congruent markings, right? Meaning each of those points are in the middle of the sides of a triangle. Okay, and those triangle midsegments, there's a special property about these midsegments. The triangle midsegment theorem states that the midsegment of a triangle which in this diagram here, the midsegment is DE because D and E are midpoints on both sides. 2 things. It's parallel to a side of the triangle, the side that it's not touching. Parallel segments do not intersect. And its length is half the size. Okay, so here you can see DE is parallel to BC. And then if DE were x, then BC would be 2x. So we'll state that here. DE is parallel to BC, our midsegment, and DE is half the length of BC. All right, so let's use that property or use that theorem to find some lengths of midsegments in these triangles. Let's do A and B together. So we want to find the length of UW. And UW is definitely a midsegment, right? U is a midpoint, W is a midpoint. You can see by these congruent markings on both sides. That means it's going to be half the length of the side that it's parallel with. Parallel, these aren't intersecting. So take your 7.4, use your calculator if you need to, cut it in half. The length of UW is 3.7. Let's try B, the length of JL. So JL is not a midsegment. JL is the length of a side of this triangle. But PN is a midsegment, and PN has a length of 36, which means the side that it's parallel with would have to be double that midsegment's length. So 36 times 2 to get us a length of 72 for JL. 72. Okay, go ahead and try and find C. We're looking for the measure of angle SVU. SVU. Okay, this was a tricky one. I wanted to see if you guys could remember the properties of lines intersecting parallel lines and the angles that are formed. This is a transversal right here, and this angle, 41, is an alternate interior angle with angle SVU, so SVU is also going to be 41 degrees because alternate interior angles are congruent, so 41. Remember your two properties of midsegments. Parallel to the side that it's not intersecting and half the length of that side. Two properties for your triangle midsegments. Okay, plenty of practice on these problems on the homework tonight. Don't forget to check your work, and we'll answer any questions you have in class.